Assalamu alaikum all viewers and welcome back to your own channel. The place where you can watch and learn about a lot of things. So please subscribe to my channel, like my videos and share it with your friends. Today I am going to tell you some basic information about tolerances in concrete construction. This is the most important topic for all civil QC engineers and civil supervisors because you will hear at least one question from this topic during your interviews. So please watch this full video with patience and attention. Here I am going to tell you about tolerances suggested by ACI for RCC buildings. Before jumping into the topic details, I am going to define you tolerances. So it is defined by ACI as the permitted variation from a given dimension or quantity. But here a question arises in our mind that why do we need tolerances in engineering? You should answer this question like, as an engineer, we must try our best to get a quality and perfect products. But always getting 100% perfect products is impossible because the production of a product depends upon a variety of factors like human errors, environmental effects, defective tools and materials, and many more. Also, a lack of tolerances lead to improper fits. It will also add to delays and higher costs. For your understanding, I am going to present you a simple building plan of 45 feet by 25 feet, in which we have two sizes of footings, F1 and F2. The size of footing F1 is 2 feet 6 inches by 2 feet 6 inches and the size of F2 is 5 feet by 2 feet 6 inches. The center to center distance between the footings are 10 feet. Before shifting the building drawing from a page of paper to the ground, you must know about Pythagoras theorem and its applications. It states that within a right angle triangle, hypotenuse square is equal to the sum of the squares of other two sides. The simple numbers used for this process are 3, 4, 5. Take 3 meter at A side, 4 meter at B side, so we will get C is equal to 5 meter. It means our angle is right angle. This is the first step to be used for reducing the errors regarding the positions and eccentricities of the structural members and to get the corners of your building exactly 90 degree and to get the corners of your slab and staircase even. Variation of the linear building lines from established position in plan and related position of columns, walls and partitions should not be greater than 1 inch in any case. Means you must lay out your building carefully and with great precision. Now coming to the tolerances for footing sizes. ACI states that variation in dimensions in the footing plan is equal to -1/2 inches to 3 inches. In this plan, the red dotted line shows that these three footings have same dimensions and are aligned with each other. So according to ACI, we can reduce the size of a footing up to half inches or can increase the size from 2 inches to 3 inches as shown. Similarly, on the right side you can see that the center of footing F2 coincides with the center line of other footings in both directions. ACI also sets some tolerances for the eccentricities of footings and columns, which states that you can only displace the center of a footing by 2% of the footing width in the direction of the displacement, but the total changes in the eccentricities should not be greater than 2 inches. This displacement might be on either side. as shown. Variation of the distance between walls, columns, partitions and beams is equal to quarter of an inch per 10 feet, but not more than half of an inch in any one bay, and the total variation should not be greater than 1 inch. The mostly asked question in interviews is that how much tilt is allowed in a concrete column, or what is the tolerance for the verticality of a column. So the answer is that only 3 mm of tilt is allowed per meter, but the total tilt should not be greater than 2 cm. This criteria is same for both short and long columns. This error can be reduced by checking the verticality of the column for mark by using spirit level and plumb bar prior to the concrete pouring. Similarly, the depth of the footing should not be reduced by more than 5% of the specified depth of footing in drawings as shown. Variation for the plumb in the lines and surfaces of columns, piers and walls is equal to quarter of an inch per 10 feet for inside the buildings and is equal to quarter of an inch per 20 feet for exposed corners, column and other outsides of a building. Similarly, the sleeve sizes in the floor openings and wall openings should not be decreased more than quarter of an inch or should not be increased half of an inch. Similarly, variation in the level of columns, beams and slabs from the level and from the grades indicated in drawings will be discussed here. As you can see, footings are below the natural ground level and columns are above natural ground level. The dark dotted line shows the specified level of column top in drawing. So according to ACI, you can move up or down from the specified level up to plus minus 1/4 inches per 10 feet and plus minus 3 or 8 inches per 20 feet as shown here. The same criteria is for beams and slab levels. Similarly, the tolerances for the thickness of slab and concrete walls ranges from plus 1/2 inches to minus 1/4 inches, means we can increase the thickness of a concrete wall up to 1/2 inches and can reduce it for 1/4 inches. When it comes to the tolerances for concrete stairs, according to ACI, we can vary the tread of a stair step up to 1/16 inches and the rise of the step up to 1/8 inches. Hope you learned a lot of things from this video. Thanks for watching my video, and for more videos please subscribe to my channel Allamj Mahasar 24, and please like and share this video. If you have any question, please mail me on the given email address. Thanks, bye bye.